The next company on the list is obviously Hushmesh.
Yes.
Manu is going to be talking about the work that they're going to be doing.
That's right. The problem with skinny jeans is that I cannot put my phone in my pocket. So my name is Manu Fontaine. I'm the founder and CEO of a public benefit cybersecurity startup here in the Northern Virginia area. And our mission is to build the new web. You can think about we call it the mesh, and you can think of the mesh as a global information space, just like the web, but with automated cryptographic security and universal zero trust built in. So I can hear you thinking, this is crazy, this is nuts, it's never going to work. So I want to put things in context, and I want to ask, show of hands, who had a phone like this in the 80s? Who had a brick phone? Come on, don't be shy. A few people had this, right? Great. So the 80s were a great decade. So it was the beginning of a lot of things. You know what else was invented in the 80s? The World Wide Web was invented in the 80s. So other show of hands. Who is building apps on the brick phone today? Nobody, I hope, right? And yet, we are still building apps on the web today. So you see where this is going, right? The web is a 35-year-old technology that has no built-in security whatsoever, and that essentially requires privileged insiders to operate the information space. It's quite simple to look at the topology of the web. If you have two entities, and by entities we mean person, organizations, digital things, physical things that need to connect with one another across the internet, and if you want to do it over the web, you have a domain in the middle. There is no global verification mechanism at all. It's not possible. So you cannot verify, you must trust. This is the opposite of zero trust. And of course, Web 2.0 was great. We just put APIs, we connect everything together. The same problem just explodes. Now we have an attack surface that turns into a game of whack-a-mole. So it's time to turn the page and to embrace an information space that has all cryptographic security built in and fully automated across a network of secure chips. We call it the mesh. And the mesh is underpinned by the universal name system, which generates identifiers for all entities across the universe. I'm not kidding. Unique identifiers for people, organizations, digital things, physical things, and the universal certificate authority that cryptographically binds keychains to each one of those entity identifiers. And then that infrastructure enables you to then fully automate cryptography, automate key exchanges across the internet, thanks to a technology called confidential computing. So if you don't know what it is, most people don't know what it is. It's microelectronics innovation on the server side. Basically, confidential computing chips can be remotely verified across the internet. Then they can verify the software or give you cryptographic evidence of the software that runs on those chips at that moment in time. If your software runs cryptographic libraries, now you have verified cryptography, which means that your software agents, can have confidence that every bit that goes through the computing environment can be signed, encrypted, decrypted, verified. When all is said and done, you end up with a topology that looks like this. The UNS and the UCA is a hierarchical recursive infrastructure, very much similar to the DNS. And then people and organizations, agencies, governments can deploy their own mesh servers. They all automatically connect to the UNS UCA. They get verified. They can create their own identifiers, their own keychains. And then they can automate key exchanges and pairwise cryptography across the internet. So if you take that diagram that I showed you, you rotate it a little bit, and you see that the three-party model is basically native in that infrastructure. Every entity in the mesh is an issuer, a holder, a verifier. Now, these are not web credentials. These are symmetric verifiable credentials, if you want. We use symmetric cryptography within the infrastructure. But the goal here is to use this groundbreaking infrastructure to basically build a proof of concept that would show that we can use that universal zero trust infrastructure to create agents that will bridge with the web and support the cryptographic requirements that DHS has for the W3C VCDM wallets and verifiers. So we will do that in parallel alongside the messaging application that we're developing. You guessed it, messaging is messaging through the mesh. And we're building that right now for NATO Diana. And the two applications, the two use cases will be fantastically complementary. So you've been warned. The web is a dead end, and you should start building on the mesh today. I'm sure you're going to have some questions.
So recognizing that some entities are considerably slower in adopting new technologies or transitioning than others. I mean, my job was giving me a pager just 20 years ago, and those brick phones have been out forever, and they were already shrinking. So it takes a while to get that. So assuming that the wallet or the credentials that we plan to issue will reside in the mesh, will people who need to verify those from outside the mesh still be able to use them? Because we don't want to wait for everybody to abandon the 35-year-old infrastructure to be able to use these things we're trying to develop now.
No, the intent is to fully support the standard and be interoperable with legacy web verifiers or web issuers. We see the adoption problem, right, is always the same. The web started with one server, with one website under, somewhere in Switzerland, right, or at the border between France and Switzerland. The mesh is non-existent or, very early stage right now. And then the name of the game for us is to create the bridges between the web and the mesh, and then let the gravitational force of universal zero trust migrate and pull applications and data within that verified infrastructure.
So I guess I get a little bit confused when, so the intent is interoperability, and the proposal is a new internet that everybody has to get on in order for it to work. But the intent is that it will be backward compatible and that it will work with the current. I agree that the web is dead. You can't trust anything on it. I agree. But the intent is to work backwards. So 2 questions. How does the intent look in a concrete way for the mesh working with the current awful web we have? And who is the governance? How does this new mesh, what body or bodies are the standards where it evolves?
All right, fantastic question. I guess the first part is, no, not everybody needs to be on the mesh to be able to use it in web applications. We actually support OpenID Connect, identity provider solutions to mesh into applications. We have a REST API that enables you to then leverage the mesh as a SaaS infrastructure. So there's a bunch of ways that this can be gradually migrated. The intent is to say the mesh is a inherently authentic, inherently verified infrastructure that can scale at internet scale. We're not there yet, right? It's going to take a decade to get there. There's going to be a lot of work by other people, a lot of eyes to look at this thing and see if it works. We think it does because the primitive at the core of the mesh is extremely simple, highly scalable, high performance. And so the name of the game for us is to maximize the network effect and the glide path, right, to just enable applications onto the mesh natively. And the things that we are looking for or looking at are all the critical supply chain use cases. For instance, on the commercial side, we have a relationship with AMI, which is the leader in firmware supply chain. How do you transfer firmware updates from one place on the internet to all the places where it needs to go in the cloud server markets, for instance, with assurance of provenance, integrity, and confidentiality? The mesh enables that. So there's a bunch of use cases that can tactically enable us to get to some level of scale, and then from there, we hope and we believe that the network effect is going to kick in.
Is this competitive or in the same line as trust over IP?
Trust over IP is very much about human governance, human trust, and how you organize your trust framework. This is automated, zero trust. So we don't trust, we verify. So
the governance is under the company, the .com.
No, we only govern the verification engines, if you want. We don't govern the uses. So any company will be able to deploy their own mesh servers. They'll be able to deploy sub-meshes. So just like the governance of the DNS, right? You govern the DNS. It doesn't mean that you govern every application, every use case on the web. Similar concept.
Well, Jody had stolen my question, but I'll ask it again because I'm not sure you answered it, which was, if this was the next web, where are those standards being developed?
Right. So we are at the IETF right now. We thought going to W3C, but obviously the message of saying, the web doesn't continue forever is not really well received. At the IETF, similar types of consideration. This is a completely new approach. Engineers are pretty stubborn. There's a lot of stuff that's going on, but we're trying to plug ourselves into the critical working groups, understand how they work, and then over the next couple of years, we think that that's where the work should happen, because this is an internet layer infrastructure, right? This is not on top of the web. This is really next to the web, but it very much is an internet layer type infrastructure.
Thank you, Manu. I will simply add to one point here. One of the reasons we are actually funding Hushmesh is basically we see this in a very point solution, which is basically how do you manage cryptographic scale, how do you distribute and manage cryptographic keys as it relates to verifiable credentials and decentralized identifiers, right? So, but obviously Hushmesh has broader plans than that. And last but not least,